So without wasting time, we'll now quickly go into the programming bit. So I'll because you have access to all these codes, you can practice at your own pace. There are already existing videos you can also watch on my YouTube channel to also explore further. But now here, I'm just going to touch more on things that I believe is also important that has not been captured yet. All right. So without wasting time, now to do any statistical analysis, the first thing is to be able to import data into the software. So it means even if you are a user of SPSS or you use SAS or you use, let's say, Python, the most important thing is that how to import data into the software is the first thing. Now, if you're able to import data into the software, technically, you don't need anyone else to help you. There are so many online information out there. So let's say you want to fit a generalized linear mix model, and you've been able to import data into let's say R. The rest is, how do you do that? You just go online, go to Google. Now I'm going to use ChatGPT to help those things, and fine. So what I'm trying to imply is that importing data is always the first thing. But to do that, what we need to do is to set something called a working directory. There are so many ways of importing the data. The easiest way is to set a working directory. Now I'll stop sharing and then explain what I mean by working directory. So let's say I created a certain folder. This folder, all of you will have access to that. Now I created a certain folder and I have, so it means in order to import a data, first of all, your data should be in a certain folder. Now that folder is called what? A working directory. Okay, so it means on my desktop I've created a folder and I've named it NUGS-China 2000 and whatever, and then I want to import some specific data set. So all I need to do is that data should be in that. Here I have SPSS data, I have Stata data, I have SAS data, I have different data. Different data, all within the working directory. Now, to create a working directory, all you need to do is you click this bit. So you see this bit, you copy this address. This particular address is what we mean by your path. So, and basically it specifies completely your working directory. So keep in mind that in order to import data, all you need to do is that go to the folder of interest, then and then click here and copy this particular address, and that is your working directory. Now we will see the importance of that because it makes life easier. I'm trying to share. Okay, fine. So now let's go back to the file. Fine. So anytime you copy a working directory, all these things I've covered them. I'm just touching them a bit on here, but they are already on the YouTube channel. The moment, all you need to do is that we use something called setwd. It is what we use to set working directory. I told you programming languages, the term language means that there are specific codes or instructions that you need to know in order to communicate with the software. Some of those things you don't need to memorize or you wouldn't know offhand, but over time you become what conversant with most of them. Now you open this quotation and you paste. Anytime you paste the working directory that you copy, the link or the path, you realize that this how do you call it? Is it backslash? It slants towards what? The left, but you have to change it what? To the right. So this is the only thing you need to do. So you change it to the right. You change it to the right. You are just changing the backslash to /. And that is, if you don't do that way, let's see what will happen. Suppose I didn't change it. And then I decided to run that. Okay, so it will give me some error message. Fine. So keep in mind that anytime you copy the link, all you need to do is that change all the backslash to /, and then you're good to go. Fine. So that is how, so upon running that, it means I have set working directory. All these codes here, you can just easily copy and paste into the RStudio, and it will also give you output. But I will encourage people to, over time, to learn how to use Jupyter Notebook, because you can clearly see it has so many advantages. Fine. I've created a function. This function, I've called it Novel Summary Computation Script. So this is a function I think if you watch the first lesson in my YouTube class, there was, as part of the session, we wanted to create a certain novel summary statistics function, like a function that you can use for summary statistics, irrespective of any data, in an automated way. So what we did is that it's a function which picks any data. It can take any data set. It's and then you don't need to specify whether the data is, the variable is numeric or categorical. If it is numeric, it will compute some numeric measures for you. It will compute the mean, median, kurtosis, skewness, and everything. And then it can even plot histogram for you and choose different colors. And then if it is categorical, let's say you are trying to summarize some set of categorical variables, all you need to, it would compute the percentages for each levels of the categorical variable, and then also do a pie chart for you and choose different colors, irrespective of the number of categories. So that's the function I've created. I wish to create it as a package. So it means this particular function that I'm talking about, suppose in order to use it, because I've not created a package yet. So what that means is, let me quickly share this, what I mean by that. So in the folder, so this is the name of the function. So it means I created a script. Okay. So the same way initially when I started the RStudio tutorial, I just said that always you need to create a script, right? So I created a script here, but this script, if I should write it as a package, then it means you have to install that package in order to use every function that I've specified in this particular script. But because I haven't written a package for this particular script, in order to use the package, in order to use the function, then we use something called source. So this source is a way of what? So the moment I write source and I specify the name of the script here, and I run, it is just similar to if I had created a package and then you use install.packages to install the package and you loaded it. If you load it, it's just similar to doing the source. So it means anytime you store a package and then you load it, it is actually doing the same thing as this. But because I haven't written a package for that, then it meant that I had to source it. So it means stop writing long script. If you are trying to create a function and you know that that function is very long, you can create a separate script for that and use the source function to call it anytime you need it, rather than having long list of long code there. So this is what I mean by installing packages. So it means in R, you can use install.packages. If you are using RStudio, you can do it manually. And so let's say you were searching for how to do regression analysis online, and the moment you saw a blog in R, and the moment you opened it, you saw that someone has written library of something. It means that those things in there are what we call packages. You have to install those packages in order to be able to use the associated function that the package can can allow you to work with. And then in order to install, since I'm not using RStudio, then I have to write the code, the code itself. So we use install.packages. Don't forget that you should always bring the quotation, quotation signs, and then you specify the package in there before you run. But when you are loading, so here, when you are loading, you can choose to ignore, or you can choose to bring the quotation sign and it will still work. But when you are installing, don't forget that you need to bring the quotation. But if you do it in R, you can do it manually, and then just as I specify at the beginning of the class, and then that is also another alternative. Fine. So here, there are instances maybe you are doing a publication and they want you to choose a particular resolution of your figure. So here I've specified 300. It means you can set it as 500, especially if you want your figure to be high quality. But keep in mind, the more you increase the resolution, it also makes it, too much of everything is bad. So 300 is averagely okay. Most of the times public journals specify at least 300 to 500 should be sufficient. So that's why I've specified 500. Yeah. All right. So here we are going to learn how to import different data structures. So that is the next item. So here, in order to import CSV, you don't need a package in order to import CSV file. Now, someone will say, what is CSV file? So let me, or how do you create a CSV file? Fine. So let me quickly show you. So when you have an Excel data, you can import the Excel data directly into R. But keep in mind that in order to import an Excel data into R, you need a package, a certain package to import the Excel data into R. However, when you convert the Excel data into a CSV file, then it means you don't need a package in order to import CSV files. So CSV files are the easiest way to import packages in most programming softwares. Okay, so to convert, so let's suppose this was an Excel data, and I want to convert it to CSV. I just have to click on File, and then I click on Save As, and then of course browse here, and then the Save As type, you choose CSV from here. And the CSV, keep in mind, we have different versions of CSV. You have CSV, UTF. All you need is CSV, delimited. That is what you need. You don't need CSV, MS-DOS or Macintosh. You are looking for CSV, delimited. And then you click Save. So the moment you do that, then it means that you've converted your Excel data to CSV. So this is to say that when you have Excel data, the easiest way to import it is, first of all, convert it into a CSV file before importing. Fine. So because I've set a working directory, remember I've already set a working directory, meaning that I've specified the folder that all my data sets are in there. It means that the moment I now specify the name of the data, and then since it was a CSV, so I have to include the extension .csv, then it means I can now easily import data. So now using head is just, and then I specify n to be 10. I want to see the first 10 rows. All these things are things I've already covered. If you start the YouTube videos from the beginning, just watching the first 2 videos alone, you realize that you know everything you need to know in R and how to do import data. I mean, do a lot of other stuff in there. So this is just a quick overview. Fine. So here, if you want to import data, a CSV data, this is how we do that. And then the tail will let you know the last. So if you specify n to be 6, then you want to know the last 6 rows of your data. And then so this is just to know that you've imported your data. Fine. And keep in mind, in R, you can import multiple data sets at a time. If we're using, let's say, SPSS, you realize that in SPSS, you cannot have more than 1 data set at a time. So it means if you are doing an analysis, unless you open a different SPSS data set, so it means you have different data sets. But in R, it means you can have multiple data sets and you can switch between the data sets. So that's the beauty about using programming softwares, in that you're able to import multiple data sets at a time. You can, and then after importing the data, I realized that I called it as meta rate. So this is what I mean by an object. So that at any point in time, the moment I run this, then it's more like I'm trying to run the data. Okay, so that's why every code you write, you should store it in an object. So by object or assign it to an object, this is what I mean. And in R, you can either use equal to or this. The less than with that also indicate assigning. Fine. So that is how we import SPSS data. It's so straightforward. And keep in mind, it should be in the folder, okay? But you should set your working directory. And then the next thing is how to import Excel data directly if I didn't want to change it to a CSV. So it means that I also have a particular Excel data called transform data Excel, and then I want to import it. But since it's not in a CSV format, I need this package in order to be able to import that. So that is why I'm saying that if your data is in Excel, always remember the easiest way is to first of all save it as a CSV and import. Otherwise, you need to do this. And most of the time, if you import a data, most times they are unwanted. The first column is not needed because the first column is just like specifying the number of rows in the data, right? So this is a way of eliminating. So it means that after importing this data, let me just come here. If I'm interested in knowing the variables of the data, I can use names of that, and that will specify all the variables in the data. Let's say I want to extract the first column of the data. All I need to do is to put 1 here. So keep in mind that everything at this bit is for the rows, and anything after that is the column. So if I specify 1 here, I'm talking about the first I'm talking about the first column. So it means that is it. If I'm interested in looking at the first 2 columns, I need to bring this C sign and then specify 1, 2. This C sign is called the concatenate sign. So keep in mind that without, anytime you want to create a vector, you need to bring that concatenate sign. If you don't bring it, it won't work. So it means that I can't just write, let's say 1, 2 and run. It will not run. But if I indicate it this way, then it works. So that's what we mean by concatenate sign. You don't need to be confused about this. Like again, you can start from scratch and you'll be fine. Fine. So here, this one will extract the first 2 columns. If I'm interested in the first 2 and then the last, let's say, and the fifth or the sixth, you can also indicate it that way, and then you get it in that format. So this is how we extract data. Let's say I'm interested in the first, the second, and the fifth columns, but I'm only interested in the first 20 rows. So in that case, when you do it this way, then you also, so it means always this first bit is for extracting rows, and this is for extracting columns, and each column is your variable. So don't forget that. And anytime you want to import data, your data should look like this. So it means that your Excel data, the first row of your Excel data should be the variable names, and then you proceed from there. And then when you're importing data, don't have multiple pages in your Excel. So you realize that in Excel, you can create multiple pages in the same Excel file. But when you want to import a data, make sure that you copy that Excel page you are interested in and save it as, and give it a particular name to it, so that when you're importing the data, each data should be on a particular Excel, rather than having multiple data in the same Excel and you want to import them. That is not right. All right, so without wasting time, this is how we import data if it is already in an Excel format. Let's say I have an SPSS data called combine whatever data, and it's SPSS, and I want to import. This function will help you it will help you to import it directly into R. So it means there are instances where you have a data in SPSS, you did all your analysis in SPSS. Now you want to replicate or do the same set of analysis in R, or you want to even do more than, because keep in mind, SPSS, Stata, and those other softwares, they are handicapped in that it's not every statistical analysis it can perform. You cannot do machine learning in SPSS, for instance. So it means that R or the programming languages have advantages over the base statistical softwares, right? So first of all, it means that this is how you import data, SPSS data into R. And let's say you have data in a Stata format, and you, instead of doing your analysis in Stata, you want to import it into R and work with it. So this is how we also import. So in terms of Stata, we have 2 packages you can use. So the Haven package uses read_dta, and with this, so this is a certain Stata data that is in the folder that I wanted to import, and this is how easy you can do that after you set your working directory. And this is an alternative way of also importing Stata data. So this is another Stata data. We'll be using this data for some explorations below. So this is how you can also import. So clearly, and then if your data is in a SAS format, those who use SAS, okay, SAS, there's a way you can actually convert it into CSV in SAS and then rather import that into R, but that is a long process. You can easily also import a SAS data directly into R using this. So this helped. So at the end of the day, what we've learned so far is how to import different data from different softwares into R. And then you can now perform every statistical analysis you want to do there. Fine. Now, if you want to know the dimension of your data, how many rows, how many columns, you can just bring DIM around the name of your data, and then that will give you that. So I created this function in situations where you want to know whether there are missing values in your data. So this is a way of what? So at the moment, it means the data called Stata_data. That is what we are going to use for explorations. It's telling me that the number of missingness is 0. Okay, so I automate, and all these things you can easily copy and paste and modify it to do any analysis you are also working on. Fine. So yeah, so without wasting time, so there was another data. You remember the SAS data. So using the same function, this helps to tell all those variables that have what? Missingness, and the number of missingness in each of those variables. So it means that there are so many variables here. And then this tells the number of, if I want to actually know how many variables have the missingness, I can even type length around this one, and it would tell me that there are 197 out of what is the dimension of this data, out of the 332 variables that have missingness. And this tells the exact number of missingness as well in the data. So it's just something you could always explore before your analysis. Fine. Now, so the SAS data, and keep in mind when we imported the SAS data, they had already assigned categories to them. So it means that so this is the SAS data we are working with. So if I want to see the head of it, so the head is just the first six. If I don't bring n, automatically it does 6. Okay, fine. So so this is the data we are going to explore. But keep in mind that let me just first of all rerun it here, and then where's the SAS bit? Yes, let me run it here. Fine. So okay, yeah. So let me come down a bit. Okay, so at the moment, so this is the data we are working with. So if I want to extract, let's say 6, all I need, how we extract variables, apart from the approach or the way I showed you, you could actually you know, when we want to specify or extract a particular variable, we use the second bit here. So you could either count the index. But what if the data is very long in terms of the number of variables? Are you going to count 1, 2, 3? You want to know the position of 6. Are you going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11? Are you going to go through that? Okay, even that gave me 6 math. So okay, so this is that. Otherwise, you can also just bring a column here and type the name. Keep in mind, in order to know the names or the variable names, this is what we use to know the exact variable names. And so it means you can easily just copy the variable name here and paste it there. Keep in mind the quotation can be either 1 or 2. It will still work. Okay, it will still work. Fine. Now, another way of extracting the variable, instead of using the indentation, is rather using the $, and then you specify 6 here. This is also another way of extracting that variable, and it's one of the so anytime you see the $, it means it's a way of extracting any variable of interest. Now, since in the SAS data they've already assigned labels to the categorical variables, so we realize that the moment I bring print around this, it gives me extra information that without bringing print, it gives me extra information than without bringing the print. So when I bring the print here, it was telling me that when I see 1, it means male. When I see 2, it means female. So keep in mind, let's say you imported SPSS data, and in SPSS, you've already assigned 1 to male and 2 to female. So when you import it in R, what I'm saying is that when you extract it this way, you are likely not to see the labels. But the moment you bring print around it, you're able to also see the specific labels, so that you can now assign one, male to when it's 1 and female to when it's 2, and so on. Fine. Instead of names, you can also use column names, and that will also extract the variables. Fine. So let me just quickly. So here I'm just. So we have, if you look at the data here, we have sex, we have race, and then we have this public. This public is public school, whether it's a non-public school, public school status, whether it's a public school or not. Now we want to assign labels to these variables. You know, at the moment they've been assigned dummy variables. So it means that for the race, we have 1 to 4. I want to be able to, so for the race, if you look at the race, we have without bringing the print, we don't know the extra details, but after bringing the print, we know that 1 means Asian, 2 means that, 3 means that, 5 means that. So now we want to be able to tell R that anytime it sees 1 and that race, it means Asian, and so on and so forth. So, and this is how we assign labels to any categorical variable. So for sex, so it means you extract the sex variable from the SAS data, and then you indicate the variable and the labels. So it means that in order to know the labels, so at the moment, if I click on levels, it tells me now. The reason is because R sees sex at the moment to be a numeric data. although it is not numeric because you've assigned it as 1 or 2. So in order to really know the levels, I can now bring as.factor around this. And then if I run this one, it will tell me that the levels are 1 and 2. Fine. So this is just to say that this is how you will be able to tell the specific levels in the data. And then since I know that 1 means male, this is how we specify if it's 1, it means male. If it is 2, it means female. For public also, when it's 0, it means non-public. And for the public too, you could also know the label. So you realize that you don't just say when it's here, it's 0 and 1. The reason is because that's how they enter the data. So if I should type levels, and then I have to bring the as.factor because currently it's numeric. So if I run this one, it tells it's 0 and 1. So here, if it's 0, it means public. If it is 1, it means non-public, and so on. So this is just a simple way of what assigning labels to the categorical variables. And then you can now find frequencies, you can find percentages with this. You can even do cross tabulation. So if you come down here, if the table function is what we used to do frequencies, and then I can divide by the total number to get proportions. I can even multiply by 100 to get it as percentages. So by the moment you use table and you bring another variable inside the table, it will do a cross tabulation for you. So this is just how you can do cross tabs in R, straightforward. Fine. And then the SAS data, you remember now I have assigned here at the moment, if I run 6, it's just 1 or 2 and 1 or 2. So now after running this one, you realize that 6 has now turned into female and male. Now, if I do the same for public, so it means the public at first it was just 0 or 1. Now you see it has used the labels. So you have non-public or public and so on. For the race, it was at first race was 4, 1, 2, 3. Now, if I should run this one now for the race, you can clearly see we have white, we have Asian, and so on and so forth. Fine. So and now you can do your the cross tabulations and anything you want to do. Fine. And then it will be based on the labels you assign to that. Now, imagine I exported the SAS data. It means that after importing it into R, I can now export it into any format I want. So this is how we now export. When you mean by import, means that you are bringing the data into the software. Export is that you are taking the data out of the software into your working directory. So we use write.csv. If I want to export this SAS data that I have now assigned the labels to it, if I want to export it as CSV, this is how we do that. And if I want to export the same SAS data rather as an Excel, this is how we do that. If I want to export the SAS data as an SPSS data, this is also how we do that. If I wanted to export it as a stata data, I just have to bring .dta and specify here to be SPSS. As stata, and then it will export that as well for me. So this means that situations where someone has a data in SPSS or let's say SAS, and the person wants to convert it into Excel, it means even without doing any statistical analysis, you can easily import that data and export it as what into any format of your choice. So that is one interesting thing you can do. Now the next thing is, please, how many minutes do you have at the moment? Hello? Please, can you hear me?
Yes, Doc, we can hear you.
How many?
Yeah, you have.
Yeah, please, I can hear you.
Yeah.
We have 30 minutes more.
Oh, great. So I can now. So we are now getting to the most interesting part. Please wait for the ChatGPT because you really need it. Fine. So so this is how so I have created a function. I told you I created a certain novel function, and then I've already explained at the beginning that it's a function that it picks any data you've imported, and then it asks whether the variable is numeric or not. If it is numeric, it computes the mean, median, mode, standard deviation, and you can modify it to do any additional whatever you want. And then if it is categorical, it finds the percentages and then does a colorful pie chart for you as well. So it's a function that I created on my own. But when you start the YouTube channel, you see how we created that, because we started it one at a time, not just that. So you'll be able to see how we created that. When you start learning how to create functions in R, we have a whole YouTube video on how to create functions in R, how to do statistical analysis, everything is there. So don't forget to visit the YouTube channel to learn more about that. Fine. So now, so this is how the function is. So the function, we call it summary stats. So it means that you have to specify any data you want and just specify the index. So here, if I put the index to be 1 and I run, it tells me that the variable name is called this. And then keep in mind, I didn't know whether that variable whose index is 1, I didn't know whether it's numeric or not. I can put even 3 or 4, 3 here, and it will give me some output. And it tells me that the variable is called SES, and it specifies the mean, the median, skewness, and then in the interquartile range as well. So this is my function, and you can easily use it to summarize any data that you've imported into R. So it's something I hope to write a package around it. Fine. And the beauty is that you realize that here I specify plot.graph to be false. The moment you write it as true, for true, you can either write it as T or capital letters true. If you run this one, it would also, instead of the, in addition to the summaries, it will add a plot for you. The moment you set it as false, you can either use capital F or write false in capitals, and then it will eliminate that. Fine. And keep in mind, this is when it's 3. If I had specified plot to be true, and then to be true, let's see. So you realize that the first one, the graph, it chose a different color, which is green. Then the other one, it chose a different color. So that is how I've specified that in the code. So anytime you specify a particular index, it chooses a different color for that. All right. So so here I specified index 13 because I knew that index 13. Suppose I didn't even know what the index 13 was. It will tell me that the variable was race, and then it specifies the percentages, the frequency, and it chooses a nice histogram with these colorful or chooses different colors for each level. And so it means any data you have, even if the categories are 20, it will choose different 20 colors and specify the percentages as well for you. So this is the function that I've created. Fine. So that is the bit that I wanted to explain about how to do some basic statistical summaries in R. So the next session is, so this is the last but one session, is how to use ChatGPT to help with your programming, not just for programming, for anything you are doing. It can be, the whole point is that it's an AI or artificial intelligence, right? So what that implies is that just like any machine, you have to use it with caution, right? But when it comes to programming, because it's an AI and programming is based on AIs, so what that means is that it's relatively 100% accurate when we talk about that. So here I've written a list of tasks that I wanted ChatGPT to do for me. So now let me open ChatGPT here. So I'm sure you all know how to create a ChatGPT account. So if you want to create a ChatGPT account, all you need to do is just go to Google and type how to create that account, or just type ChatGPT, and then you'll be able to create one from there. So this is how it looks. You can type anything. Suppose I was interested in explaining something for me. So here I was interested in it explaining, I just type explain the concept of, let's say, group sequential design, and then it summarizes a top level summary of what group sequential design is about. So it means you can use it for anything you are interested in. Now I'm going to create a new chat. So here I have some list of what? I have some list of tasks here. We are just going to go through maybe the first 5. You can do the rest. So look at the kind of complex questions I'm telling it to do. Now I'm telling it to write a function in R to plot a line graph for me. I'm telling it to write a function in R to plot a line graph and set the color as blue. I'm going to tell it to write a function in R to perform generalized linear mixed model. I'm going to tell it to write a function in R to perform maximum likelihood estimation. I'm going to tell it to write a function in R to simulate a continuous time Markov chain using tau leaping. I'm going to tell it, how do we do Bayesian estimation in R? How do we perform Bayesian t-test? How do we perform Bayesian estimation from, let's say, any question you want. So here, I'm just asking, I was just trying to ask it tough questions to see how accurate it is, and I was really impressed. And the beautiful thing is that there are instances you already have codes in R, and you want to be able to convert your code into Python, or you want to convert your code into Stata, you want to convert your code into Julia or any programming language. The beautiful thing is that it can easily do that for you. So here we would let it convert this R code I've created into Julia language for us. And then remember that I also created my novel, the function that we're using for the summary statistics up there. I will tell it to convert it into Python for me. And it will do that precisely. And then you can ask it, how do we program Stata in R? So suppose you want to do Stata directly in R, how do we do it? It will tell you exactly how do we do Python, how do we write MATLAB function in MATLAB. It does everything for you. So now let's just try a few examples. So the first thing is, so this is how we use it. So you just type your question. So here, write a function in R to plot a line graph, and I just press enter. And so we are waiting. So it starts, and then great. And then so it has created the function, and it's even creating an example. So it means that I can actually copy this code. To copy, just click on here, and then it means it has been copied, right? And you can paste it in your R software, and then you run it, and you get your output. You get it. So that's the beauty about this. Now let's try the next one. So it means that these are precise code. So it means now once I have another data, or I extract a certain variable, I can also use this function to plot the line graph and so on. And here I even told it to choose a different color for me. So so at the moment it didn't specify. Okay, here it specified the color to be blue, because I think naturally it specified the color to be blue. So what if I say it should choose a red color? Let's see. So it means it will go through the process, and then it specifies the color as red, as you can clearly see. Now let's just and do something a bit complex. So how ChatGPT should help me on how I want to do a generalized linear mixed model. How would I do that? All I need to do is that I just write that question. So instead of asking me, at first people would call me and ask me a series of questions, and now you don't need me. So if I say write a function in R, so I said write a function in R. I didn't even write the English well, to perform GLMM. So GLMM means generalized linear mixed model. So see how intelligent it is. So here it even tells you the package you need to install, and then it will give you it will simulate, it will obtain a simulated data, so that when you run the function, at least you get some output, so that when you import your data, you can use the same function to do that. So it means the moment I copy this and paste it in R, and bear in mind, you saw library of something, it means you have to install this package first. Anytime you see library around something, it means whatever there is called a package, and you need to use install.packages. Open your brackets, bring your quotation, and specify the package. If you are loading, you can choose to ignore the quotation or not. Now let's say you want to do complex stuff. How to perform, let's say, Bayesian estimation, let's say Bayesian inference in R. Let me choose, so let me say how to perform Bayesian inference in R. It's not just R, you can specify in Python or any language you want, any software you want. So if I press enter, it will give you precisely how you should do that, and it will tell you the softwares you should install. So here it's telling me I should install the RStan, and I should load the RStan after the installation. And now to do classical Bayesian inference, you have to create your model. So it's telling me how I should create the model in the Stan. You don't need to understand this. These are just for demonstration purposes. These are complex stuff. You don't need to understand. I'm just trying to say that the things it can do is limitless. It can do so many things. So it has just showed me how I can use the R stand to do Bayesian inference. Now let's do this. I have a code in R, and I want to tell ChatGPT to translate it to Julia. Julia is another programming language. It's just like R, but it's so fast. So when you want one of the most fastest programming languages is Julia and C++. So Julia is quite fast. Now let's see something. So all I need to do is, so I type the R code here, and now I'm running it. So now let's see. I want it to convert this R code to Julia. I could have specified to Python or to Stata to anything. So here it has given me exactly the same. It has converted for me, and it is even giving you specific details for you to understand the code. So it's telling you that in Julia, the function starts with, so it's telling you, it's giving you like explanations of what it has even indicated. So now you remember the function that I was telling you about. So I want to convert my summary statistics function, which is very complex. So here, so I'm saying that convert the following R code to Python. So I'll press on Shift and type enter, and now paste that long code that I want to convert. So the long code, I'll quickly open that script. Is quite long. So this is what I mean. So so it means that I have this script, and let's say my supervisor, if let's say I was doing my PhD or I was doing a research, and the supervisor, you are good with R, but the supervisor is good with Python, and he wants you to convert your codes to Python, or he wants you to convert your codes to MATLAB, or convert your codes to SPSS, or convert your code to any software. So now I want to tell ChatGPT to convert everything here. So I want it to convert this function to Python for me. Let's say I don't know how I'll convert this to Python. So I go back to ChatGPT. So now I'll paste that long function here, and then this will be the last demonstration. So now this is the long code. Now ChatGPT is converting it to Python one at a time. So this is to say that ChatGPT, although people in social science, there are people who have issues. They say let's say when you are asking it to give you some qualitative information about maybe history or something, sometimes it might not be precise. But as far as programming is concerned, it's 100% correct. So this is something I want to also tell us, that with ChatGPT, you can easily learn programming as a beginner. Let's say you've never used MATLAB before, and then you are interested in, and then it explains. The beautiful thing is that it will explain each line of code, what each was trying to do, and then after that, it will create an artificial data and run the function for me. So it meant that it has converted my function to Python, and at the end of the day, it has created a simple data for me to apply that to it. Okay, fine. So here, I've never written a function in MATLAB, for instance. I'm just assuming. And now let's say I want to know how to write a function in MATLAB. I just type that, and then it's basically so here I'm just saying how to write functions or create a function. So it's basically yeah. So it tells you that if you want to write a function in MATLAB, this is what you need to do, and then it creates. It even gives you further explanations and so on. So on this note, it means any statistical analysis you want to do, it could be you want to do maybe OLS regression. You can just type how to perform OLS regression. Let's say you are doing it in Stata. In Stata, I just type. It was still doing the MATLAB thing. Let me stop generating, and then now how to perform OLS regression. I didn't bring in Stata, but it will understand that I meant in Stata, and yeah, so it just tells you that in Stata, this is how you go about it. So trust me, I think it's quite useful for those who really want to learn or do any statistical analysis, want to convert codes to different languages, or want to even learn programming from scratch. This will really take you through the step-by-step and so on and so forth. Now, the last bit, which would is just the last bit to wrap up the class, is to do some advanced data visualization. On the YouTube channel, I've already covered a lot of videos on like complex visualizations. But here I was particularly interested in something called slope graph, which I want to market it to you to use it for your research as well. Because in most times you realize that most people will be collecting data, and they are collecting data at multiple time points. How do you visualize that change? How do you visualize that repeated measures or repeater measure data? How do you visualize that? So this is just a way of what demonstrating how to. Here I've created a certain function. What it does is that it's, if we have a certain data, this is the SAS data, and I wanted to extract all the quantitative variables, this function I've created would do that for you. So you don't need to memorize how I did it. You just have to use it. And then if I want to extract categorical variables, it does that for me. Fine. So here we are just and there's a way of also, based on my own function, the function that my summary statistics function, based on this code, it means that you can set it up such that for your data, it will compute all the numeric. So these are the numeric variables of the data, and it has summarized it in a nice table. And then there's a particular function I've added here, and this function would export your table into an HTML file. So what I mean by an HTML file is that, let me open that HTML file. So it means that it will export it, and you have the summary in this way, where you can click on use a browser, any browser, and then it will export. It will show you your summary results in a HTML file. Fine. And then alternatively, you can also export it as a latex file. So those of us into mathematics, you realize that we don't use Word documents to produce our documents or for writing up, even our research. We use something called latex. Latex is maybe another thing I could do a YouTube channel, video on. It's actually very useful, especially if you want to write scientific reports, publications, and so on and so forth. So all my research works, all my publications, everything was written in latex. My PhD thesis, everything was done in latex. Fine. So it means that there are instances where people have to now manually create the tables in latex. With this line of code, it means that it will automatically create your tables in a latex format for you. And so that's the beauty about that. Fine. So and so this is how you can summarize all the quantitative variables in terms of their means, their median, and so on and so forth, based on my function, and it does that for you. And then if it is categorical too, you can also summarize all the categorical variables and specify their percentages here. So at this case, I wasn't interested in the plot. I just wanted to get a top level summary of all the categorical and all the quantitative variables. Fine. There are instances where you want to do a regression, and then you want to look at, explore, or investigate the correlation. Remember I said that if you want to fit a linear regression model, you expect the predictor, let's say the continuous predictor, to be linearly related with the dependent variable. If there is non-linear relationship, then you have to consider either transforming that variable. Transformation can affect data interpretation, or you want to fit splines to smoothen out the non-linearity. So if you look at this graph, so this is how you can do correlation matrix plot, such that you can clearly see it tells many things. Apart from the fact that it gives you the distribution and whether it appears to be normally distributed or not, it also gives you the pairwise correlation between each. So here it means that this negative 0.52 is the correlation between the variable called time and rate. Okay, so where they intersect. So it means that this particular value is the correlation between convection and rate. Okay, where they intersect, and it's not significant. Fine. And here you can specify whether you want to use Pearson, whether you want to use Kendall, Tau, or Spearman correlation. You can specify that there. And so this is a much more fancy way of investigating. And keep in mind here, where you also have a scatter plot, and it tells the kind of relationship that exists. So suppose that rate was my dependent variable, and I wanted to fit a certain regression. No, let me assume, let's say convection rate was my dependent variable. Was my dependent variable. And then there's a certain variable called FP. Now you see this FP and convection, it's intersect here. you can clearly see that the line plot is curvy, linear. So meaning that it looks quadratic in shape. That means that if I'm trying to fit a model where FP is an independent variable, and I'm using a linear model, I might get poor fit in the sense that there's a nonlinear relationship between FP and then convection. So if I was using additive model, I can either choose to add first splines to this particular FP variable, and that will make it fairly linear like this one. Okay, before you now use your regression. So this is a fancy way of investigating correlation matrix plots. So don't forget that you always have to do this kind of stuff before you do your regression modeling, so that you have a fair idea the kind of relationship you expect to see, and then so on and so forth. And even this one also tells that those that are predictors, are there significant or high correlation between some of them, and it tells you that there's likely to be a multicollinearity in that case, and then it gives you advanced knowledge of what to do when the model is poorly fit.